Hi, my name is Nancy, and today I'll be presenting my model, which is used to predict the total UPDRS for Parkinson's disease based on voice measurements. So, what is PD? It's a progressive neurodegenerative disorder, and its symptoms span across motor and non-motor domains. So, why does it matter? It affects more than 10 million people worldwide, and currently the gold standard, which is the MDS UPDRS, is done in clinic and it's infrequent, so it results in late diagnoses. And for MDS UPDRS, it's the Movement Disorder Society sponsored revision of the Unified Parkinson's Disease Rating Scale. It's divided into 4 categories, which are behavioral mood, daily living, motor exam, and therapy complications. The category is divided into sub-items, and they are all rated from 0 to 4, totaling to 272 points, with higher points meaning more severe PD progression, with a baseline at 32 points and plus or minus 13. And the goal of the project is to estimate the total score of the UPDRS. And this is an example of the questionnaire. So, why choose voice measurements specifically? 70 to 90% of the PD patients show voice changes and is also an early indicator because sometimes the symptom of voice changes precedes limb signs, and acoustic features are also objective and repeatable. The source of the data is from the Oxford and collaboration with National Center for Voice and Speech dataset, in which there is over 5,000 recordings from 31 patients, and the 23 speech features is analyzed and found no missing data, and the features will be compared with the total and motor UPDRS. So by comparing with the baseline, which is done by a multivariable linear regression on all 23 features, the predictors correlation and coefficient, and after considering domain insights, will be ranked based on their values, and will be finally selecting a 6 feature that has the highest correlation with total UPDRS. And then a 2-layer neural network will be used to analyze based on the 6 features and predict the total UPDRS. So this is a correlation heat map. We can see that this is showing the correlation between the different predictors with darker shade of red, meaning higher correlation. And the true versus predicted total UPDRS, this is tested on 80% of the training data and 20% testing data set. And then this is using all 23 columns. And then this is the 6 final selected features, and they are the motor UPDRS, HNR, RPDE, DFA, Shimmer, and PPE. They are the features that have the highest correlation with the total UPDRS. And after selecting and dropping the features that are critical and dropping the features that are non-critical, we have the final 6 features, and this is the trend it's showing. And then we can also see that the training and validation loss decreases very rapidly. And then after using the only 6 selected features, we created a 2-layer neural network and used to predict the total UPDRS. So the results for the 23 feature initial prediction is that the R-square value is 0.91, and then the 6 feature LS has a negligible drop from 0.91 to 0.9 for the R-square value, and for the 2-layer neural network, the R-square value is 0.94, as well as a low RMSE or root mean square error of 2.49. So overall, it's a well-adapted model. And then the 6-feature model predicts a total UPDRS with strong accuracy again, and then because it's only 6 features, it has minimal operational burden design and can easily fit into current clinical workflows. However, the limitation is that it relies primarily on vocal measurements, and the results are likely coming from only one clinical source. So in the future, it will be nice to include other phenotypes such as motor and non-motor symptoms, and future work should also test from multiple clinical data sets to decrease selection bias. And here's the reference. Thank you again for listening.